Deep in the twilight of our solar system, a traveler from another world approached the sun as closely as it ever would. And in that moment, everything went differently than expected. Late October 2025, the mysterious interstellar comet known as 3I Atlas swept around our star. Instead of the usual bright glow, it erupted in a sudden burst of activity that left astronomers puzzled. Jets of vapor and dust spiraled up from its surface. Its tail, strangely enough, twisted at times, pointed directly toward the sun, a behavior unheard of for comets. This was no ordinary wanderer. When Atlas passed through perihelion, its closest point to the sun, it was being observed by spacecraft. Within just a few days, it became brighter than well-known comets at similar distances, far exceeding all predictions. Today we'll break down whether this was simply the result of the object's extreme speed, its unusual internal chemistry violently venting into space, or a sign of something far more unexpected. Could this interstellar object have been a probe from an alien civilization? The story of 3I had actually begun several months earlier on July 1, 2025, with a small signal in telescope data. At an observatory in Chile, the Atlas cameras recorded a fast-moving point of light that matched neither a typical comet nor an asteroid. Within a single day, astronomers realized they were witnessing a historic moment. The third confirmed interstellar object ever discovered. They named it 3I Atlas. 3I marking the third interstellar visitor, and Atlas honoring the telescope that detected it. It was a wanderer from another star system, racing along a hyperbolic trajectory so steep that the sun's gravity could never hold it. It was approaching at more than 36 miles per second, faster than any known comet. At the moment of discovery, humanity gained a rare opportunity, a chance to study material from an alien star system, a pristine fragment of another world. A worldwide observing campaign began. On July 21st, the Hubble Space Telescope quickly captured several images revealing a faint coma, a hazy atmosphere surrounding the object and giving astronomers the first clues about its size. It turned out to have a small nucleus, likely less than a mile across, hidden beneath a growing halo of gas and dust. By August 6, 2025, the James Webb Space Telescope had also turned its gaze toward our visitor. What JWST detected only deepened the mystery. Chemical signatures in the comet's spectra unlike anything ever seen before. Data from JWST's infrared spectrometer, along with observations from NASA's new Sphere-X mission, revealed a stunning composition. Carbon dioxide was extraordinarily abundant, vastly exceeding the amount of water vapor. In fact, the CO2 output was roughly 7.6 times higher than that of H2O, the highest CO2 enrichment ever recorded in a comet. For comparison, comets from our own solar system typically produce far more water than carbon dioxide, often tens of times more H2O than CO2. And it wasn't just the CO2. The carbon monoxide content was also unusually high, about 1.6 times greater than the water production. Another striking sign that this object's chemistry did not match typical cometary profiles. The spectral fingerprints revealed something even stranger. The reflected light of 3I was extremely red. Its surface or coma exhibited one of the reddest spectral slopes ever observed in a small body. This coloration suggested a surface coated in complex organic material, dark carbon-rich compounds that may have formed after eons of exposure to cosmic radiation. Unsurprisingly, scientists soon proposed that the outer layer of this comet had been cooked by the galaxy. Over billions of years in interstellar space, high-energy cosmic rays likely transformed the comet's ices and organics converting its originally volatile materials into more carbon-rich compounds and even turning CO into additional CO2, a thick 16-yard crust, a layer about 15 to 20 meters deep of irradiated material may blanket Atlas's surface, explaining both its unusual chemistry and its reddish coloration. In fact, the comet we see is not truly pristine. Scientists realized, with a hint of irony, that 3I Atlas might not be the pure messenger from another system they'd hoped for, but rather a weathered traveler whose surface has been reshaped by millions of years of drifting through harsh interstellar space. And the strange behavior didn't end there. As the summer of 2025 progressed, 3I Atlas continued to act in ways that defied expectations. Several teams reported the detection of exotic gases that are rarely visible in comets. Using the Very Large Telescope in Chile, researchers observed something unprecedented. The object's coma contained glowing vapor of nickel, but no detectable iron. Nickel and iron are heavy metals that appear as vapor in solar system comets only when those comets become extremely hot. Yet here, nickel gas was being released by an interstellar object still far from the Sun, at several astronomical units, where temperatures were far too low for metals to boil. Even stranger was the absence of its usual companion, iron. Detecting nickel without iron suggested that some unusual process was selectively releasing nickel atoms from dust grains, possibly through a low-temperature chemical release or a photochemical effect. In other words, 3I Atlas was literally venting heavy metal vapor in a way that contradicted the known physics of comet behavior. Meanwhile, other observatories studied the comet's behavior in polarized light, primarily observing how its dust and gas scattered sunlight. The polarimetry analysis brought yet another surprise. The object's signature did not resemble the polarization patterns of any known comet or asteroid. When viewed from 3 different angles, 3I displayed a deep and narrow drop in negative polarization. In simpler terms, the way Atlas's dust reflected sunlight left a unique fingerprint unmatched by any known object, even the previous interstellar visitor 2I Borisov. This indicated that the dust particles were different in size or composition from those of all other comets we've studied. Another layer was added to the growing list of oddities by 3I's trajectory. Unlike the 2 previous interstellar objects, which arrived at random inclinations, Atlas traveled almost along the plane of the planets, within 5 degrees of the ecliptic. It was also on a retrograde path, moving against the direction of the planetary orbits. This meant it would pass near the inner planets. In early October, it flew about 17 million miles from Mars, and in early November, it approached Venus's orbit. Statistically, such alignment of an interstellar comet's unusual, though not impossible. Some estimates put the probability of this happening by chance at roughly 0.2%. To some, it seemed too perfect, as if the comet had been intentionally directed into the solar system. Of course, astronomers note that this could be a selection effect. Comets approaching the ecliptic are simply easier to detect from Earth. Naturally, the ones we do find are often those near this plane. Nevertheless, the object's orbit and timing sparked rumors that 3I Atlas's trajectory might have been precisely calculated, especially given how conveniently it passed behind the Sun from Earth's perspective at its closest approach, almost as if it were trying to avoid detection. This intrigue laid the groundwork for several theories that went beyond conventional scientific explanations. With each new anomaly, nickel without iron, excess CO2, the sunward-pointing anti-tail, hyper-fast perihelion brightening, and bizarre polarization, the buzz grew louder. What exactly was 3I Atlas? A comet, yes. But could it be something more? some members of the scientific community and many in the public sphere began openly wondering whether these phenomena might be signs of an artificial object. After all, the extreme CO2 outgassing and unusual tail orientation were even whimsically compared by some observers to a propulsion exhaust. Others pointed to the extraordinary nickel release and speculated the object might be metal-rich debris, perhaps even a fragment of some technological artifact. Speculation ranged from cautious to fantastical. Was 3I an abandoned alien probe using a comet-like disguise, or perhaps the spent exhaust of an interstellar spacecraft venting gases? Could its passage near the planets have been intentional reconnaissance? Mainstream scientists have been and remain highly skeptical of such claims. There is no credible evidence supporting the idea that 3I Atlas is anything other than a natural comet. In fact, in many ways, the object behaves just like a comet. It has a coma and a tail composed of typical gases. It brightens as it approaches the sun, and its dynamics are consistent with outgassing forces. The hypothesis of an alien spacecraft rests largely on the mystique of the unknown and a series of coincidences. As one planetary scientist noted, for every unusual feature of 3I, there are a dozen completely comet-like traits. Nonetheless, the discussion is healthy. It reminds us of the need to keep an open mind. What if one day an interstellar object truly turns out to be artificial, yet we miss it because we continue to dismiss that possibility? By mid-November 2025, Atlas had passed its encounter with the Sun and appeared in the morning sky of the northern hemisphere, albeit only as a faint shimmer in powerful telescopes. The comet not only failed to calm down but continued to captivate scientists as it began its outbound leg. After perihelion, observations focused on detecting any changes. Would the object's composition alter after experiencing more intense solar heating? Interestingly, 2I Borisov, the previous interstellar comet from 2019, had shown a compositional shift. Its water-rich coma before perihelion transformed into a CO-dominated coma afterward, possibly due to surface stripping. For 3I, one of the key questions was whether it would finally reveal pristine material from beneath the cosmic ray processed crust. As of the end of 2025, initial analysis show that even near perihelion, the comet lost only about 3 feet of its surface, far too little to breach the 16-yard thick process layer. There remains the possibility that as the object recedes toward the stars, further activity or even fragmentation could expose fresh ice from its nucleus, giving us a glimpse of its original composition. However, such an outcome is uncertain. It is certainly worth noting that uncovering these anomalies would not have been possible without the exceptional coordination between ground-based observatories and spacecraft scattered throughout the solar system. In particular, NASA's SWIFT satellite, equipped with an ultraviolet optical telescope, made crucial early detections of water vapor emanating from 3I Atlas while it was still over 3 astronomical units from the Sun. In late July through August 2025, SWIFT detected OH molecules, a characteristic product of water breaking down under sunlight, indicating that the comet was already releasing water at a significant rate at such a great distance. Based on these observations, scientists estimated that more than 8% of the comet's surface was actively sublimating water ice, far higher than in a typical comet. To produce the observed water vapor at these distances, a patch of ice measuring at least 3 square miles would normally be required. This early activity suggested that Atlas might have large regions of exposed ice or highly volatile ices on its surface. As 3I approached, even our planetary neighbors joined the observations. In early October, when the comet made its closest pass to Mars, spacecraft orbiting the red planet turned their instruments toward it. the European Mars Express and ExoMars Trace Gas Orbiter attempted observations during the flyby. NASA's Mars Reconnaissance Orbiter succeeded in capturing images of the comet from Mars orbit, showing a faint, diffuse coma and the object's trajectory against the backdrop of the starry sky. Meanwhile, NASA's MAVEN spacecraft, designed to study the Martian atmosphere, detected ultraviolet hydrogen emission surrounding the comet. These observations provided a unique three-dimensional view of the extensive hydrogen envelope, something that simply could not have been observed from Earth. Next, the observational baton passed to JUICE at Jupiter, which prepared to attempt remote observations in November 2025 as the comet traversed that region of the solar system. Drawing ever closer to the center of our system, the galactic messenger became an object of study under the watchful eye of a global cosmic telescope. Now, as 3I Atlas returns to the darkness of interstellar space, we're left to reflect on just how remarkably diverse these visitors can be. This is only the third one we've ever observed, and each one has been unique. The first, 1I Oumuamua, discovered in 2017, was a complete mystery. It appeared as a tumbling asteroid with no coma, yet it exhibited slight acceleration as if something were gently pushing it. Oumuamua was extremely small, just a few hundred yards in size and likely pancake or cigar-shaped, unlike any comet we'd previously encountered. The second, 2I Borisov in 2019, was much simpler. A clear cometary object with a visible tail and familiar gases. Yet even Borisov had its peculiarities. It was very rich in carbon monoxide, far more than typical solar system comets, suggesting it formed in a colder, CO-rich environment. Borisov even broke into fragments as it left the Sun, possibly due to thermal stress. And now, 3I Atlas has rewritten the rules once again. It's undeniably a comet, like Borisov, but in terms of composition and behavior, it's far more extreme. For one, it's larger and faster, but perhaps more intriguingly, it carries the chemical imprint of deep time and distance, an object possibly older than our own solar system itself, with an estimated age of 7 to 14 billion years. Its ices have been exposed to cosmic radiation, producing unprecedented chemical compounds that release exotic gases and even metals. Its dust and light scattering properties match nothing we've ever seen before. This underscores that there's no standard template for interstellar objects. They can be as diverse as the stars from which they originate. The story of 3I is at once comforting and humbling. It's comforting because even in its strange behavior, we find natural explanations that expand our understanding of cometary science, teaching us about cosmic ray processing, volatile chemistry, and the range of comet activity. It's humbling because it reminds us how little we've explored the universe beyond our own system. These objects are but a tiny fraction of what surrounds us. Atlas leaves us with new mysteries. How common are comets with such high CO2 content? Which star system could have launched a comet on a 6 billion year journey while completely baking its surface? Could truly artificial objects exist among the stars waiting to be discovered, or will all such visitors turn out to be strange yet natural? In the coming months, this interstellar traveler will move beyond the reach of even our most powerful telescopes, vanishing into the darkness where it will drift for millions of years. Yet the impact of its visit will be felt in laboratories, observatories, and the imagination of people here on Earth. We face the task of analyzing an enormous volume of data. It will likely take years to fully understand this event. The legacy of 3I will also shape the future. Plans for new telescopes and rapid response missions are fueled by the knowledge that these interstellar visitors are out there, ready to bring clues from distant worlds. Astronomers are already refining their search methods, hoping to catch the next interstellar guest even earlier, perhaps fast enough one day to send a probe. Current models suggest that once operational, the Vera C. Rubin Observatory could detect dozens to hundreds of interstellar visitors per decade, turning rare anomalies like 3I Atlas into routine discoveries. And so, the remarkable journey of 3I Atlas leaves us with a sense of awe. It came from an unknown star, traveled longer than our world has existed, and for a brief moment became part of our neighborhood, a wandering enigma shining under our sun. What other secrets, natural or perhaps even artificial, lie out there among the stars, waiting for the day, too, they visit us?